Hello, this is Rick from MathX, and today we'll be doing number 28 from the 5th-6th Math Kangaroo of 2019. Now, this is another deceptively easy 5-pointer, as even though there's a lot of words and visuals involved with this problem, this problem can be solved quite simply using nothing but logic and simple time skills. So, without further ado, let's just jump into the problem so I can show you how easy it is. Every digit on my digital clock is composed of at most 7 segments as follows: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But unfortunately, in every set of 7 segments, the same 2 segments don't work. At this moment, my clock shows something, something, something. What will it show after 3 hours and 45 minutes? And then it proceeds to give us multiple answer choices. So, in this problem, it lays down simple context. We have a digital clock. The maximum number of each digit can be comprised of is 7. And in every set of 7 segments, the same 2 digits, the same 2 segments do not work. Meaning that if this segment and this segment don't work here, they won't work here, or here, or here. So, just using some common sense, we can extrapolate some numbers starting off. Since we're dealing with the digital clock here, we know that the number of hours ranges from 0 to 24. That means that this first digit either has to be 0, 1, or 2. We see that it cannot be 0 because 0 would have its middle bar empty, but this one has it filled, so it can't be 0. 1 won't have any of these horizontal bars filled in, so it can't be 1. So using this, we can extrapolate that the first digit is 2. Now, this first digit was supposed to be 2, but we see that this failed to show, and this segment failed to show. Meaning that these are the 2 faulty segments that will fail to show in every other digit. And we see that's the case. In this digit, we don't see these 2 digits. In this digit, we don't see these 2 digits again. In this digit, we don't see these 2 digits again. The 2 faulty segments, we found them. So, we can try to figure out what the next digit is using some extrapolation. So, we've already deduced that the first digit in this time is 2. Now, since the time can be 0 through 24, and we've already figured out the first digit is 2, this could either be 20, 21, 22, 23, or 24, meaning that this second digit could either range from 0 to 4. We see that it cannot be 0, because then it would not have its middle horizontal bar shaded in, but it does, so it can't be 0. It can't be 1 either, because then it won't have any of its horizontal segments shaded in, but it does. We also know that it cannot be 2, because then it would not have this vertical segment shaded in, but it has that too. We know it can't be 4, because then it won't have this top horizontal bar shaded in, but it does have that too. So the only number we haven't eliminated is 3, meaning that this second digit is 3. That makes sense, because then this digit will fail to show, and then this one would also just be fine. As for the next digit, well, we know that 2 segments are failing to show, and we know that these 2 failing segments are this and this. If the time is right, this segment is not going to show anyways. But if the time is right, this segment's also not going to show. If the time prevents it, then both of these segments would show up, and they would form this weird number. However, we know that the figure formed by these segments is not a number, meaning that the only number that this could possibly be is 4. And thus, we see that this digit would have to be 4, because we anyways know that these 2 segments are the faulty segments. We can use the same kind of logic to determine what this final digit is going to be. We know that these 2 segments are faulty, right? So, from there, if the time would permit it, then these things would show up, and we'd get this weird figure. However, this would not form a number we know, unless we get rid of this other segment. Once we do that, we're left with this segment that resembled 7. Thus, we can see that this final digit is 7. So we see that the time that it currently is 23:47. If we want to find out the time 3 hours 45 minutes from now, well, the time 3 hours from 23:47 would be 23 plus 3 minus 24 to 47. That would be the time exactly 3 hours from 23:47. Now, if we want to find the time 45 minutes after that, we find that as 3:32. So by using some simple calculations, we find out that the time 3 hours and 45 minutes after this pre-established time of 23:47 is 3:32. So we see which one of these could be 3:32. Remember, this segment and this segment are faulty, so they won't show. However, the rest of the segments that would make up 3:32 would show. So let's look at these answer choices and see which of these could be 3:32. Now, if 3:32 was written on a digital clock, it would be written as 03:32. So we see which of these would resemble if 3:32 was written as a digital clock. In that if we put the faulty digits back of their places, which of these will look like 03:32? So let's look at this first case. We know that the faulty segments are this segment and this segment. So if we put these back together in each of these numbers, we can see what number we'll get. So if we do that, we see that this first digit is a 0. If we do that in the second digit, but hold off this one, we see that this resembles a 3. So right now we're matching the first two numbers. Do the same thing with the third digit, but refrain from this segment. We see a 3 once again. And now if we fix both of these segments in this final digit, we get a 2. This time resembles the 3:32 that we know is the time after 3 hours and 45 minutes. And taking account for the faulty segments, we know that this is our right answer. So, in conclusion, we solved this number 28 on a 5th, 6th Math Kangaroo. It was a little confusing, but using some common sense and simple time knowledge, we've solved it. All we did was we used some common sense to figure out which two segments didn't work, apply it to each of the other digits to figure out what digits they would resemble, deduced the time, added 3 hours 45 minutes to that, and then interpreted how it would look like on this faulty clock. The conclusion is, on problems like this, you always have to try doing something. In this problem, we could have sat and stared at it as long as we wanted, but we wouldn't have gotten anywhere. By taking initiative and starting to apply the knowledge that this problem gives us to the problem, we were able to do something. And we saw that this number 28 wasn't as bad as it seemed.